Hello, you are welcome to today's lesson. This is the part 2 of the OSI model lesson. In the part 1, we saw what an OSI model means, the layers of the OSI model and how data is transmitted through the first 3 layers of the OSI model. We learned that OSI simply means Open System Interconnection, a concept laid down by the ISO that governs and directs how network devices should work to facilitate communication. We also learnt what happens at the layer 1, that is, the physical layer, through the layer 3, that is, the network layer. Kindly watch the part 1 of this lesson before you continue with this one if you haven't done so. In today's lesson we will continue with the layer 4, that is, the transport layer. In this layer, data is broken into segments and the necessary port number through which the data should be transmitted is attached. To explain this further, let's consider the following scenario. In most cases, a user may be multitasking his PC or device, meaning the user may be accessing more than one application or service on his PC. For example, this user may be accessing Facebook.com, Google.com, and any other service from same computer. When this happens, ask yourself, how does each application sends information over the same physical layer and receives the right response from their respective servers? What happens here is that, at this layer, each service opens a random port number and attaches it on the data being transmitted so that the respective server can send a response through same port number. This port number could either be TCP or UDP port, depending on the application being accessed. We shall extensively look at what TCP and UDP does in later lessons. So, this layer 4 will include a header in addition to the already discussed layer 2 and 3 headers. This header will be a port number that will then determine which particular application receives which data stream or data segment when there is a response from the server to the client PC. This makes sure the right application receives the right data segments. So, for a successful response from this server to the right application, which is the Facebook application, the layer 4 header, which is the source port number that this application used in establishing the connection, will then be attached here as the destination port number. This is usually called service-to-service connection. This layer also carries out flow control, meaning sending data at a rate that matches the connection speed of the receiving device, and also carries out error control, which means checking if data was received correctly and if not, requesting it again. The 5th layer is called the session layer. The session layer creates communication channels, called sessions, between devices. The time between when the communication is opened and closed is known as the session. This layer is responsible for opening sessions, ensuring they remain open and functional while data is being transmitted, and closes them when transmission is completed. The session layer also sets checkpoints during data transfer. So, if the session is interrupted, devices can resume data transfer from the last known checkpoint. For example, if this server is in the process of transmitting 1 GB of data to this client, a checkpoint would be set, keeping record of already transmitted data size. So in case there is an interruption during the process, the session could resume from where it ended when the connection is restored. This is one of the reasons why you can continue your downloads after interruption in applicable programs. The 6th layer is the presentation layer. The presentation layer takes any data transmitted by the application layer and prepares it for transmission. By so doing, it defines how devices should encode, encrypt, and compress data so it is received correctly at the other end. This is because 2 communicating devices may be using different encoding methods. So layer 6 is responsible for translating incoming data into a syntax that the application layer of the receiving device can understand. if the devices are communicating over an encrypted connection. Layer 6 is responsible for adding the encryption on the sender's end as well as decoding the encryption on the receiver's end so that it can present to the application layer with unencrypted, readable data. In simple terms, encryption, compression and decryption takes place in this layer. The last layer, which is the 7th layer, is called the application layer. This is the layer that directly interacts with data from the user. The application layer is used by end-user software, such as web browsers and email clients. It provides protocols that allow software to send and receive information and present meaningful data to users. Examples of such protocols include Hypertext Transfer Protocol, File Transfer Protocol, Simple Mail Transfer Protocol, etc. This brings us to the end of the OSI model lesson. Again, the goal of this lesson is not to memorize the various layers, but understand and know what happens at each layer during communication. To wrap it all up for academic purpose, we can look at this summary and study it. This has been grouped by the main functions of each layer, addressing type and devices where applicable. You can also take note of the names of the data stream at each layer. Thank you for watching and subscribing to this channel. Please share for others to watch if you find it helpful. See you in the next lesson.